Welcome back, team. Welcome back to another video. For those of you that are taking Math 3 or another class that has to do with coordinate geometry or circles, welcome back. In this video, we will be focusing on circles and looking at different aspects of circles and how to answer questions about circles, and using a little bit of coordinate geometry. How can we make sense of circles when it comes to needing to find the circumference or area, or finding just different pieces of them if we aren't given them. So with that, let's get started. Let's look at Unit 2 in terms of circles. And for some reason, my software loves to automatically make shapes or circles when I try to draw or write certain words. So circles, the first thing that we're going to do with circles is think of some objectives that we're going to be needing to look at when we are dealing with circles. The first one is going to be calculating the circumference of a circle. The circumference we'll talk about in just a little bit. It's similar to the perimeter, although since a circle arguably has one side, some people say it has no sides, we can't calculate it the same way, the perimeter that is, as any other shape that has multiple sides. Okay. The second objective is going to be calculating the area of a circle. Okay. The third piece of this is going to be having to deal with the circle in terms of coordinate geometry. I can find, or I'm going to use the word translate, which means like you take one version of something and then you translate it into another, not language, but into something else that you need, or deriving. I can translate given information. Now, luckily for this, one objective that we're not going to have is going to be graphing or modeling a circle necessarily on a coordinate plane, but instead it's going to be I can sketch a circle. And we'll talk more about that in just a little bit. When it comes to graphing or modeling, I'm going to write that in a parentheses here. When it comes to graphing or modeling a circle, sometimes it's easier if you just sketch it. We can't always get a perfect circle unless we're using computer software such as Desmos or the graphing calculator. And so because of that, it's going to be nice if we can sketch a circle and then look at certain pieces of information about them in order for us to make sense of them. Circles, that is. Okay. Another objective, this one we'll see if we can get into in this video, but something that we want to do is being able to calculate, and I did it again, the radius and test points. And what I mean by testing points is to see whether or not they're in, on, or outside of a circle itself, and we'll see if we can get to that by the end of the video. This will be another long video, so hopefully you're here with me the whole time. If not, that's okay, but let's get started. So the first thing we should do is we should talk about the different formulas that we're going to need for the first two objectives. So what I'm going to do over here is I'm going to call them formulas, and then in parentheses I'm just going to write circles. And I want us to calculate certain things, but we need to know the formulas in order to do that. So the circumference of a circle, and as I said before, this is similar to the perimeter, or it would be the perimeter in other shapes because a circle is round, so there's not really like sides that you can add up, versus like a hexagon where you can just add up all the sides. With a circle, it's a little bit different because it's one smooth shape, so it's a little bit harder to add up anything if you don't know what to add. So for this, the circumference has to be a relationship using the value pi. So the circumference of a circle, or the circumference in general, is going to be 2 pi r. Okay, and r in this case is going to equal the length of the radius. Some people just write the radius, but I do want to really articulate that it's the length of the radius, and a lot of students tend to get that a little bit confused. So for this, let me go ahead and draw a circle here. Boom, boom, boom. This is a beautiful circle. Let me see if I can get it a little bit better. Boom. Beautiful. The radius is from the center of the circle, and it's the line segment that is created from the center of the circle to one of the boundary points. And with a circle, the radius will be the same no matter where you draw it in the circle. That's not a radius, that is crooked. Okay, no matter where you draw it, it will always be the same length of r. Okay, and so the circumference is a relationship to the radius, and we have to use a value of pi. Well, if you notice, 2 pi r, well, the 2 in the r, if we were to reorganize this to be 2r pi, which we can do because of the commutative property of mathematics, we see that this 2r, if we have 2 of the radius, you may remember from your middle school days, if we have 2 radius put together, 2 radii put together, then that equals the diameter, which I will use as little d pi, or as others like to call it, pi d. So depending on how you want to do this, d is going to equal the diameter. So there's a couple different ways that you can articulate the circumference, and I just like to stick with 2 pi r because oftentimes we'll have r, and I don't want you to have to do extra work in order to find what the diameter is to solve for one of these. Okay, so that's the circumference. Let's look at the area. The area, and I like to put a little circle underneath so I know that we're finding the area of the circle. I'm going to put an equal sign over here so we can keep things orderly. The area of the circle also has to do with pi. And pi is the relationship of the circle, kind of how many radii it takes to kind of go around. The outside of the circle is a relationship. Pi comes out all of the time. So pi 3.14, it's actually equal to the number of radii that is located around the circle. So you got 1, 2, 3, and then 0.14 of another one. So we'll talk about that later on. But the area of a circle is going to be pi r squared. Okay, you can always remember because the area is units squared, and the area of a circle has pi r squared. So you can tell that because it's going to be squared units, we're trying to find the inside area of the circle, that pi r squared is going to be that area value. Okay. Now, those two we're going to be using to help us kind of persevere in our problem solving and take a look at what we need in order to answer some questions. But in particular, what I want to do is I want to quickly stop and look at down here, calculating the radius and then testing points. So if we're given some sort of circle arbitrarily, okay, here's another circle for us. Let me go ahead and move this a little bit. Sometimes we're going to have a center value, and the center is some point x and y. And then we're going to be asked to discover what the radius length is. And we may have some sort of boundary point. And we may know that it's on the boundary, but this line isn't given to us. So maybe we have a boundary point over here, or maybe it's down here, or maybe it's just right in between the two. And we don't have this length. I'm going to put a little question mark here. We don't know what the radius is. So sometimes we need to calculate the radius. Well, if you refer to the other video dealing with coordinate geometry, you may know that calculating the radius is the same as finding the distance from the center of the circle to a boundary point. Now, if you don't know that a point is in fact a boundary point or that a point is the center, then this doesn't work. But same thing, calculating the radius, you should be able to find the distance from the center to that boundary point and use the formula that we used before. So what this is going to be is r, now that we're finding the radius, is going to equal, if you refer to the other video, we have the square root of whatever the boundary point is, I'm going to call that our second point, minus the very first point that we have, squared, or the center, added with the difference squared of the y values. And so here, I'm going to put a little note. This is where x1 and x2 is going to be the center. And then, oh, I'm sorry, not x2. Let me correct that really quick. x1, y1 is actually our center, or whatever, our center. I'm going to refer to it as the center point. And then our x2, y2 will be whatever our boundary point is. Okay, so you can go ahead and look at that and you can compare it, or you can solve for that using the distance formula. Okay, now when it comes to testing points, let's say I have some point here, and I want you to tell me, is it in, on, or outside of the circle? You may be able to use your eyes. A lot of people can go ahead and look at this and you could say to yourself, hey, this is outside the circle. It's easy. I can see it. But sometimes when we make a graph, let's say I do something like this and then I draw a circle that looks like this. The point is just kind of off center. And then I'm graphing it myself and I graph something that looks like that. Okay. Yeah, I'm going to put a big old question mark here because we're human. We can't always make a perfect graph. And so check out the graphing video to see how you can get it the best you can by using your pencil and paper. But we can't always get a good graph. So I'm not sure whether or not this is in, on, or out. And I can't trust my eyes. Okay. We can't trust our work. Okay, and that's a little side or a little sad fact, is because we're not always perfect. We can't always trust our work, but we can trust math. We can trust testing it. So testing a point is going to help us kind of see whether or not a point is in, on, or outside of the circle. And so in order for us to do that, and I'm going to put a little note over here, testing a point. What we're actually going to do when we're testing a point is we're going to find the distance from center to the desired point. Okay, so in this case, I want to find the distance from, let's say, this center here, and I want to go all the way to this point, and I want to know what that distance is. Okay, I want to find that distance. I'm going to look at that distance, and I'm going to determine a couple things using that distance. Okay, so I'm going to find the distance from the center to the desired point and compare with the radius. And so here's what we're essentially going to do. I'm going to use the same formula from above. I'm going to use the distance formula. So this time I'm just going to put d for the distance. Okay, same exact formula. Just one we're working with the radius. The other one we're just working with the distance. So x2 minus x1 squared plus y2 minus y1 squared. And what I'm going to be doing is I'm going to be comparing that with the radius. And so if we look at this picture, let's say, for example, we're looking at this image down here. And let me zoom in for us so we can take a look at it a little bit better. Okay, let me delete or erase kind of all of this stuff, and let's break it down a little bit. So I have this circle. It's not the best circle, right? I'm just trying to articulate something here. So here's the center. We have x1, y1 for this center point, and then we want to test some point over here on the boundary. Now, I'm human, so maybe I made a mistake. This is x2, y2, just arbitrarily, and I want to see whether or not this point here is it in, on, or outside of the circle. So I'm going to go ahead and make a little note: in, on, or out. Okay, and because I've done this and I want to test it, I can't trust the graph that I drew, so I want to see whether or not this line, I'm going to find the distance between those two, right? So I'm going to go ahead, I'm going to find the distance between those, and that'll give me some value. I'm going to put a little question mark, and what we're going to do is we're going to compare that, because if I knew that what the radius was, then I know for certain the distance from the center to this point, which is going to be a boundary point, is going to be defined as r no matter where we are on the outside of the circle. So what we're going to do is, if we find this distance between this point here, the center, and the desired point, we can compare that with r. And so if you look at this image, we can see that if this distance is larger than our r, our radius, then in fact this point is going to be outside of the circle, because it has to be a length of r in order to be on the point itself. And if it's a little bit bigger, then it's just beyond the boundary. If it's inside the circle, then that's going to be less than r. So let's make a note of that on our um, formula sheet or document. If in this case d is going to be greater than the radius, then this means our point is outside of the circle. If d equals whatever value that means for our radius, then we know that the point is actually on the boundary of the circle. And if d, whatever the distance that is less than our radius, then we know that the point is inside of the circle. And we will be able to play with that as we continue. Not in this video though, but here are some formulas that we may need for today depending on what kind of problems we're working through. So I'll go ahead and I'll leave those there. Okay, so how do we deal with circles when we're answering a question? Well, let's look at a specific example and see if we can make sense of it. So the example that we're going to be looking at is fairly simple. It's just a sentence and a question. And that's going to be a circular track. A circular track is going to be 200 meters. Has a diameter of 200 meters. How far is it around the track? So let's talk a little bit. Let me add a space in here. It's bugging me. So what we need to do is we first need to see if we can get a little sketch going. Sketch of the circle. Okay, so for here, I'm going to go ahead and I'm going to draw my very own perfect circle. That's not very perfect. Boom, circle. And it says here that we have a diameter of 200 meters. The diameter of a circle runs from one boundary point through the center to the other boundary point. Oh my goodness gracious. Let me get a straight line here. Boop, boop, boop. Okay, we make these a little bit bigger so it fits. So the diameter from here to here is going to be 200 meters. Looks kind of like a Pokeball. Okay, 200 meters. And we're going to use this as a basis for us to kind of move forward. So sketching a circle, I want to put a little X by it because we've done that. And if we look at our objectives today, then we can verify that we've indeed looked at this graph and we have sketched a circle. Now, we need to start understanding what does the question actually ask us. So I'm going to zoom in a little bit so we can kind of see something. It wants to know how far around is the track. So I want to go ahead and take my red pen here. How far is it around the track? Well, let's try and think to ourselves what's around the track. So if I'm here, boop, 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 and I'm a runner, and I want to go around this track, and there's a circle, and maybe you don't want one. I want to go all the way around this track, and let's assume that I run it in a straight line. That is going to be the same as the circumference. So we can identify that in this specific problem, we will be able to calculate the circumference of the circle. So what I want us to do is I want us to kind of identify a couple things. One, we have the diameter of the circle, and the circumference, I'm just going to put C. I'm going to put a little 0 underneath, or a circle underneath. We know that the circumference equals 2 pi r, or we also said it equals pi times d. But we can use this formula and go ahead and answer some questions. Well, this one's pretty straightforward because we know what d equals. We don't know r. We would have to play around with the problem a little bit, but we know what d equals. So we can go ahead and use that formula. Equals pi multiplied with 200. Okay, now there's a couple different ways that we can go about this. One, I would accept the answer as 200 pi as your radius. And because we're dealing with meters, 200 pi meters long, or you can just put meters if you'd like. That could be one way that you answer the question. Or if you want to go ahead and multiply it out, we can see that the circumference of the circle equals 200 pi, which is going to be the same as, using your calculator here, 300, oh, not 300, 628.31 meters. And we can solve it using that. Now, let's say you didn't have, you didn't know that the circumference, or you weren't aware that the circumference equals pi times d. Okay, so let's just assume we didn't know that. Okay, if we were to go and solve this problem and do it over here this time, and we just use the formula 2 pi r, we would need to find r in this case. Now, if you recognize that the diameter is the distance from the center to the boundary point, you can assume that the radius equals the diameter cut in half. Right? Half of the diameter is going to equal the radius. So if we go to look at this, if the whole thing is 200 meters, that means that the radius is going to equal 100 meters. And so if we use this fact and we go back and we solve this, we get 2 pi multiplied with 100. We can simplify it to 2 multiplied with 100 is once again 200 pi. You can keep your answer like that in meters. Or you can do what we did earlier and reduce. Okay. So using this, we have successfully calculated the circumference. We can go back to our objectives today. And we can say, boom, I have calculated the circumference of a circle. I'm going to use green here. I've calculated the circumference of a circle. Okay. Now, that's great. That makes me feel a little bit better. But what if the question got a little bit more, difficult? Or a little different? Okay, so in another example, let's look at this one here. The distance around a circular pond is 100 feet. Will a 30-foot board be long enough to be used as a bridge to get across the pond? So let's take a look at this problem and see if we can make sense of it. So the first thing that I want us to do is going to be sketch the image, or sketch the graph, or sketch the circle. And so in this case, we have some sort of pond here. I'm going to go ahead and move this screen. We have some sort of pond here. And we know that the pond has some sort of center. Let me see if I can make this a better circle. We know that the pond has some sort of center, and we said that going around the pond is going to be 100 feet. Okay. And we want to know, is a 30-foot board going to be enough to cross it? So this is a more in-depth question. This is going to be what I consider a creative question, because it requires us to do a couple things. So first and foremost, if we're looking at the distance around the pond, we are talking about the circumference. I put the little 0 here to represent a circle. Circumference of the circle is going to be 2 pi r. And we already said that that circumference was going to be 100 feet. And what we want to know is whether or not 30 feet is actually long enough. So there's two ways that we can test this. Okay. And so for this problem, I'm actually not going to be solving anything for now. I'm actually going to be looking at the problem from two different perspectives. So I'm going to go ahead and delete this really quick because we know we're going to use those formulas, but let's talk about it. So this is going to be method 1. We know the circumference of a circle equals 2 pi r. In this problem, we know the diameter of the circle, or what we want to test, is going to be 30 feet. Which means what we should do, or what we could do, is locate the radius, which we said earlier is half of the diameter. Half of 30 is 15. And we can test whether or not this value of r equals 15 will help us get across a pond that has a circumference of 100. So I'm going to put an equal sign, question mark. This means that we're like testing. Okay, so whenever you see this, it's like, is this actually stands for, is it true? Okay, so whenever you see this symbol, it's like, is it true? Question mark. So we're going to look at it. Is this true that 100 is going to be sufficient for something that looks like this? Oops. For a pond that has a radius of 15. Okay, so if we go ahead and we solve this, we get 100 equals 30 pi. Here comes the 30 again. Remember, it's pi times d. And then we solve this. I'm going to still put the question mark there. 100, we don't know if that's going to equal. If that's going to equal 30 times pi. So if we use our calculator, we'll see that this is 94.24 feet. Okay, this is all in feet, which means that 100 is actually greater than 94.24. And we can assume that this bridge that we have is going to be too short. Too short. Okay, so that's one method. You can go just straight forward and solve for it and compare the two. Now, the second method that you can do is actually verify and see how long it needs to actually be. So this one can say, you can ask yourself, is the bridge too long or short? And in this method, we're actually looking at how long does the bridge need to be? So there's two ways of thinking about it. How long does the bridge need to be? So one way, we assume that we have the bridge. The other one, we need to know how long it needs to be. So we're going to use the same formula. I'm going to put a little circle down there. 2 pi r. And this time we're going to be solving for the radius to see, hey, how long does it actually need to be in order for us to have it? So if we manipulate this a little bit, we can see that we can start by reducing this down. Because 2 and pi have actual values. There's two ways we can do this. I'm going to do it a little bit simpler. I like keeping things in terms of pi until the very end. I'm going to divide this whole thing by 2. And if whatever I do to one side of the equal sign of the actual equation, I'm going to do it to the other side of the equation. 2 divided by 2 is 1, so those will kind of essentially reduce down to 1. And then 100 divided by 2 is going to be 50. So I get 50 equals whatever's remaining here, pi times r. I can divide both sides now because I don't know what r is. I want to solve for it. I can divide both sides by pi. If you do this in your calculator, it will give you a value. It won't just end up being a weird number or a weird situation. And when we effectively divide by pi, pi and pi equal out to 1. It's the same value. 50 divided by pi is going to be 15.915. And so this means that we would need a board, or in this case, we need a bridge that is, and if we think about it, that's only half of the pond. So what we need to do is we need to actually multiply this by 2 to get the full length of whatever the bridge is. So in this case, that is 2 times as long as the radius. And in this case, if we do this, then we get the bridge length is going to equal the diameter, which if we multiply it by 2, will give us a value of 31.84 feet. So in this case, we would need a bridge length of 31.84. So that means that a 30-foot board is actually not long enough. So once again, our bridge is too short. Okay, so there's two ways of answering this question. What I would do is I would continue with method 2, because this will give us more information. If there was another question for this, saying to ourselves, hey, you know what? I want to know how long the bridge should be. Then this method 2 will also answer this question as well as the second question. Okay, so that's another way that we can think about this. Now, we were looking at some objectives with circles, looking at some distances. There's a couple other things that we can do to answer these questions. Calculating the radius and the test points, please see the other video to kind of see how that would work. And then you can do that. We're not going to do a specific example here. Calculating the area of the circle is going to be a little bit different. Okay, so let's do a little bit of a longer problem and kind of figure out what we can do to answer some questions involving area. So one of the questions that was being asked in an example, let's see if we can pull it up here. Oh, that's the same one as before. Let me grab it from this spot. Oh, did it again. And it won't let me copy and paste it. Okay, so in this last example, for the area, we're going to calculate the area of the circle. We want to know that a box of grass seeds covers 300 square feet of ground. If a circular field has a radius of 500 feet, how many boxes will we need? So for a problem like this, we need to make sense of not only what it's being asked, but also kind of visualize it. So the first thing we're going to do is what we've always done, sketch the circle. Okay. In this case, we have a ugly circle here. Let's see if we get a better one. Boom, we have a better circle here, and it has a radius. Go ahead and delete this. Let me zoom in a little bit so that way we get a little less noise in the picture. We have a circle here. This is a beautiful field. It has a radius, which means it goes from the center to the boundary point of 500 feet. In addition, we have a box of grass seeds that equals about 300 feet squared. So we want to know how many of these will we need to cover this entire field. So what we want to do is we want to actually determine how much field do we need to cover in the first place. So we're going to be using the area of a circle, which is the value of pi r squared. And we're going to calculate the area of this entire field and then determine how many boxes of this grass seed we actually need to cover it. And there's a couple different ways that you can answer this problem. And we'll talk about that in just a second. Okay. So first and foremost, what is the area of this circle? Well, the problem already gives us most of the information. We just need to just simplify it a little bit. We have 500 squared, which means if we look at this problem, we're going to have pi multiplied with a big old number. Oops. A big old number. Okay, we have 250,000. So if we have 500 times 500, we get 250,000. And then we're going to use that value. We're going to multiply it by pi. Yes, it's a big number, but we're going to need to use this to help us figure out the rest of the problem. We have 785,398.16, I'm going to say, feet squared of land. That's a big field to cover. And so we need to know how many boxes of this do we need in order to be put into here. So if we look at this, a 300 square foot plot of land in this image could be a couple different things. It could be a plot of land that is 6 feet by 5 feet. Oh, I'm sorry, 60 feet by 50 feet. And so you can actually just draw a bunch of rectangles in here and then just kind of count how many of those will you need in order to fill up the field to this point. Or you can do the method that will maybe be a little bit easier and take a look at, okay, I know that one of these boxes will cover 300 square feet, and I want to cover this amount of square footage. So to determine the number of boxes, we're going to take the area of the circle and then divide that answer by 300 feet squared, that is, and then that should give us the number of boxes. So if we do that and we take 785,398 and we divide that by 300 boxes, we actually end up with a value of 2,617.99. Now, boxes of grass seed. Now, you can't buy 0.99 of a box, so we're just going to round up and we're going to say that we need 2,618 boxes to cover the entire lawn or field of this actual problem. Okay. So using this, it gave us the radius. If it was giving you the diameter, you should be able to do the same thing and just infer that half of the diameter is the radius. So D would equal 1,000 feet. And then you can use this information to answer any further questions. Okay. So with that, that calculates the area of the circle. We're actually going to be going through this translation of information. For example, if we're given the circumference of a value, how do you find the area and otherwise? But for now, the video is long enough. Go ahead and take a look at what we've gone through. Write down a little bit of notes, review this video, write it down on your cheat sheet, and then we'll be good to go for next week. With that, I will see you later. Have a good day.